So in our last video, we looked at the chain rule, and we looked at some examples of how to apply the chain rule, both using the Leibniz notation and our function notation. So let's consider these two functions. Let's consider f of x equal 3 to the x and f of x equal 5 to the 2x minus 3. Now in both cases, these are exponential functions, but we can't just apply our exponential rule, because if you recall, this only worked with e. And once I get away from e, the slope is no longer the exact same as the original function. It changes a little bit. And I can't use my power function because my variable is in the exponent. If you also recall from our chain rule, if I've got something other than x in the argument of my function, then I have to apply the f composed with g mentality. So here, if I'm looking at this, I can actually use both of these rules to get our derivative for both types of functions. So let's look at the function f of x equals 3 to the x and try to rewrite this. So if we think about 3 to the x, we can use our logarithm properties and our exponential properties to rewrite this in terms of e. I'm going to write it this way because if we look at this, we can see that when I bring this back up to an exponent, e and the natural log will cancel out, and I'll have 3 to the x, which is what we started with. So given that these are equivalent, then I can use my chain rule. Okay? So our chain rule says that if I look at the derivative with respect to x of e to the x ln of 3, this is going to be our derivative of e, which is itself, at the argument, times the derivative of the argument, which in this case it's x times a constant, so it's just going to be that constant. Okay? And if we think about it that way, then we can take it one step further and get rid of the e's and the ln's because of this equation we started with. This is the same as 3 to the x times the natural log of 3. Okay? So we can generalize this. If I've got a function f of x where it's b to the x, and b is some real number, then the derivative is going to be b to the x times the natural log of b. Okay. Now if we go back to that other function we were looking at, g of x equal 5 to the 2x minus 3, we can use that same generalization to get the derivative there. Again, we're going to need to use the chain rule because I'm going to have something other than just x in the argument. So here, g of x equal 5 to the 2x minus 3 says that g prime, if I follow this, it's going to be 5 to the 2x minus 3 times the natural log of 5. But I'm not done because, again, I had a chain rule in here, which means I need to multiply by the derivative of the argument, which in this case is going to be 2. Now again, for these, you've got to be a little careful how you simplify. Remember, things inside the arguments you cannot combine with things outside the argument. So in this case, there's not really a whole lot I can do. We can say this is 5 to the 2x minus 3 times 2 natural log of 5. Or if you want, ln of 25. Okay?